Good morning and welcome to Business Math class. Glad you're all here again today. We were looking at the syllabus a few minutes ago together, realized that this is section 6.5. We've got this section and one more section, which is 6.6 to complete the chapter. We will then do a computer module in the Math Resource Center, have a review, and have a test. So we're just about finished with the fourth set of chapters that we're going to do, and we'll be heading after that into the very last set, compound interest and annuities. Any questions about anything in 6, 1, 2, 3, or 4? You guys are easy. Then what we're going to do today is turn to the top of the next page on the handout, and my computer thinks it knows more than I do. I know I typed a 6.5 in there, but the computer put a 6.4. Maybe, I don't know. Anyway, it says 6.4, but it's 6.5. That's definitely a typo. I'm surprised I didn't catch it, but anyway, we're going to be talking today about rate and finding the effective rate. When we started to discuss simple interest, we discussed the interest rate at that time. Later on, we talked about discount interest, and Fran particularly was going, whoa, this just doesn't seem right. I'm not getting enough money to work with. What we're going to do today is discuss getting the correct effective rate no matter what kind of a loan that we have. When discount interest is used with a promissory note, the interest is subtracted from the face value or the principal to calculate the proceeds. So the borrower doesn't actually receive the full amount, the full principal that the interest was calculated on. Therefore, the discount interest rate is not a true reflection of the real rate that the borrower is paying. Federal government has decided that on every loan paper, the lender must reveal to the borrower the true rate, the effective rate, and it's called the annual percentage rate, often referred to as APR. Have you heard of APR before? Yeah, and it stands for annual percentage rate. So no matter how you quote rates, in the end, the one true rate or the one ruler by which you can measure and compare notes would be the APR, okay? We're going to call that the effective rate. And we need to come up with what effective rate there actually is for a given discount rate. I've come up with an example, and I'd like to look at it for a minute. They are next to each other so that you understand the situation and what kind of a problem actually exists. Let me get it up on the screen. And then let's look at it together. What I have on the right-hand side is a simple interest note, 6% interest for 1 year. We calculate the interest, I equal PRT. The interest for that would be $6. If I were the person that were lending you the money, I would then write a check to you for $100. You would, the day the interest is due and the day the note is due, 1 year later, you would repay me $106, the $100 that you actually borrowed plus the interest, okay? And that would be a true 6% APR. Discount interest note, on the other hand, works a little differently. I calculate the interest. It is indeed $6, but I don't give you the $100. I subtract the interest. I give you $94. So you've actually only had $94 to work with for 1 year. So $6 interest on $94 borrowed is not a true APR of 6%. How we would calculate it is we go to the rate formula, R equal I divided by P times T. We're going to use the proceeds for P because that's the amount of money you actually had to deal with. We're going to say that the rate equals 6 divided by 94 times 1. We're going to get R equal 0.0638. So 6.38 would be the effective interest rate. So it's really higher than 6%. Anytime you've got discount interest, the APR is higher than the simple interest rate. And does everyone see that one with the $100 and the 6%? Good. If you were ever asked to just convert from a discount rate to a effective rate or to an APR, all you'd have to do is use $100. But I'm going to give you some more precise numbers here. Let's look at the first one. It says, find the effective interest rate, or the APR, that corresponds to the given discount interest rate. You've got a 2-year loan, $5,000, 6% discount interest. Start out by figuring out how much the interest is, what the proceeds are, then use the proceeds in the rate formula to calculate the APR. First of all, is the actual answer going to be bigger than 6% or less than 6%? Bigger. That's right. Okay. How much interest are you going to pay? $600. What are the proceeds going to be? $4,400. Okay. So then what we're going to do, once we've come up with, and I'll try to zoom in on this, I've got $5,000, 6%, 2 years. Interest is $600. Proceeds are $4,400. I didn't write that very neatly. Then we use the rate formula, put the $600 on the top. What we're going to do for P is use the $4,400 because that was the amount of money you really had to use. We're not going to use the principal. Proceeds are used for principal. 2 years. Make our calculation. We get 0.0681818. We're going to round it to 2 decimal places. It's going to be 6.82. Does everyone understand that one? Okay. Next situation. Five-month loan. $13,000, 8.5% discount interest. We absolutely know we're going to get larger than 8.5 as the percentage of interest for our APR. Two-step process. Calculate the interest. Find the proceeds. Once you've got that, second step is put it into the rate formula. Do I need to zoom in on that, Holly? Okay, just a second. Are you getting 13,000 times 0.085 times 5 divided by 12 is your information that you need to calculate interest. The interest will then be $460.42. It's a discount note. Therefore, we're going to subtract the interest to get the proceeds. Proceeds, $12,539.58. And you know I do these in my lap at night while I watch TV, so sometimes I'm wrong. So is everyone getting the answer I'm getting? Okay. Be pretty embarrassing, but I do make mistakes lots. Did you figure out what you were doing wrong? What were you doing? Tell me.
I did not. Here's a clear. I took the 460.42 divided by the 12,000. So, but I didn't take it times the 5.
Okay. All right. So R equal I divided by P times T, and she was forgetting to put the T in. In this particular case, if you're using a financial calculator, you're going to need to take care of your denominator first, right? You got to handle the denominator. If you've got a calculator with parentheses, you can go ahead and put that in parentheses. I know lots of you are using different calculators, so I'll help you if you're having trouble getting the right answer in your calculator. Yeah, so you thought you were paying 8.5, but what you're really paying is 8.81. I'm seeing people still working, so I'm just going slow until you get... You're on the next one. I think they're still piddling in the back with this one, so we'll make sure. Yes, and if you've got that, move on to the next one. It's nice if you can do these on your own before we... Are you girls okay back there? Christine, do you have a question, or is Marilyn taking care of you?
I think we got it. We're just punching something wrong here.
Okay, do you need me to come and help?
No.
Okay. You've got the right numbers.
Yeah.
I have the right numbers, I'm just hitting something wrong.
Okay.
You got everything right up until the percentage.
Are you using a financial calculator?
Mhm.
Are you storing the denominator?
Mm-hmm.
And then taking the numerator divided by... Let me punch that up. Just give me a minute.
462.42.
460.42.
Divide by whatever's in your store. She got it.
Okay. I know. Which is the reason I suggest you always write everything down for me on tests, because if you've got all the right information and then you've loaded it in your calculator wrong, I'm not going to count the whole thing wrong because you got the wrong answer, you know, and it's very hard to have a feeling as to... I like to at least discuss the fact that you know your answer is going to be bigger than 8.5%. So if you're not getting bigger than 8.5, you'd know you had to recalculate. But in case your fingernails are too long like mine, or your thumb gets in the way or something, I like to give you credit for having it set up, even if you don't get it all entered, because it is hard. Okay, we're doing a 90-day ordinary loan in Part C, $1,000, 11% discount interest.
Get it this time.
First, we're going to calculate the interest, figure out the proceeds. Once we have that information, we're going to take care of the rate formula.
How far do you want us to go for the decimal? Or for the...
For the percentages,
Yeah.
I'd like the percentages to be 2 decimal places. So you can round.
Oh. I'm going one short.
Okay, so you were getting 11.3. Yeah, 11.31. I like 2 decimal places. But are you getting the right situation?
Yeah.
You're understanding how to set it up. They're whispering in the back. Is it calculator problems or it's punching in problems? Okay, because you're setting the you've got this formula correct, you're saying.
Can you show me how to store that number in my calculator?
Let me see.
Do you have time to do that?
If I
Can't figure it out. I'm not sure.
don't know if yours has a memory.
It's got that store right there.
Oh, okay.
But I don't
Then I
know.
think what you're going to do, let me see your calculation.
Okay. What'd be this right here?
I've got 1,000 times 0.11 times 90 divided by 360 equal, I think you just hit store. Now, I may be wrong about this, but I think that's all you have to do. Then let's do 8 divided by recall. That's all you have to do.
Oh.
You with me?
okay. Yeah. Thank you.
You know, yours is actually easier to work with than ours because you only have to hit store and recall.
Okay.
Ours, we have to recall and then we have to recall memory. Because on our financial calculator, we can recall other things besides memory. Okay?
Right.
And on yours, Josh, you have parentheses because you're using a scientific calculator. So if you chose, you could, and I don't have a small enough pen, you could do 27.50 divided by, and then you could just put parentheses. Do you know what I'm doing?
Yeah.
And you could use your parentheses because you're still using a scientific calculator, which is the reason a lot of times people have two calculators. There's no parentheses on our financial calculator. There are parentheses on the scientific calculator. And so for grouping, you can use the one with parentheses. That one, however, stores real easily. And I think it's nice to know how to use the memory on your calculator to get things. Did you girls in the back get 11.31 in the end?
Uh-huh.
So what are you doing wrong when you're entering these things?
Oh, well, part of it was I just hit divide instead of multiply.
Oh, okay, okay. So you're able to work with your memory and your understanding how to do that. Okay, okay. We've got another one here. It says, fold up my paper. I've got a 90-day, and it's going to be exact loan, 11% interest, $1,000. It's exactly the same problem as the one above it, only this one is exact and the one above it is ordinary. Setup should be identical with one exception. What's the exception? That's right. When we have time and it's ordinary, it's 360. When we have time and it's exact, it's 365. Should create a little bit of difference, but not a great amount in the APR.
Just in the interest, right? Not in the rate?
Oh, okay. I understand your. Okay.
That came out the same.
That's exactly what I was going to say. It's not a very significant difference in this particular problem because rounded to 2 decimal places, you do end up with, it's a tiny amount. It's only 90 days. It's 5 days more on 90 days. Bigger numbers, yeah. And so it is significant if you're in business and they're dealing in millions of dollars. In this particular case, on the first one I got 0.11311. Here I got 0.11305. So rounded to 2 decimal places, we end up with exactly the same APR. But if this was $1 million, you know, large companies, then we're talking about that it might out at 1 decimal place make a difference. But, okay, so what if someone just said, convert, and we're now off of the notes, a rate, and they gave you information, but they didn't give you how much you borrowed. Let's make up a number, okay? So I want to know what the APR is on. Give me an interest rate. Oh, $50,000. Okay. I want an interest rate. Give me a percentage. 9%. How long are we borrowing our money for? Oh, I didn't want money. That was the point of this. I don't want any money. 9%. How? 5 years. Okay, and we're going to make it discount. Okay? And someone says, what is the APR on a 5% discount note? Give me the conversion to the APR. And I don't have money. How could I do that? Plug in 100. That's exactly right. That's exactly what I would do. Plug in 100. Because, yes, you borrow 100%. We're going to figure out what part of that you pay back. And this would be like that C exercise that says double. This is saying just convert a discount interest rate to an APR or to an effective rate. So I've got a loan for 5 years, discount interest 9%. Let's convert it to its appropriate APR. Okay, so first we're going to calculate. We're just going to use 100, like 100%. You confused me, Cassandra, because you gave me information I didn't want. Okay, so how much interest are we going to pay on this one? $45. Proceeds. Proceeds would only be $55. Yeah, this is discount. So I'm not talking about how much money. I'm just talking in general. A 9% 5-year discount note, what would the APR be? So I'm just going to pick a nice round number like 100 because I'm borrowing 100% of the money. They would be keeping 45% of the money. I would only be getting 55% of the money. Yes? So we can do that even if we don't have an amount. And now we're going to calculate the rate. R is going to equal I divided by P times T. R is going to be equal to the interest that I pay, $45, over 55 times 5. The APR then would be
16.4%.
Does everyone agree? I haven't got it calculated. We just made this up. Anyone else agree? Right. So you thought you were paying 9%, and instead you were paying. So you can see why the federal government insists that lenders disclose the APR so that in every case you're using the same measuring device. APR is a standard. Can you think of any time you've seen APR?
Cars.
Uh-huh. Right. Car loans. What else? They have to disclose the APR. Right. So that's Federal Truth in Lending. I think there's a very nice write-up in the book about that coming about. It's because you would never maybe have thought that you would have been willing to pay 16.4, but you were happy to pay 9. Someone else is offering you 10 simple, and you're thinking, ooh, the 9 discount sounds a whole lot better, plus discount sounds cheaper, doesn't it? Yeah. And it's so that we can compare things and know what we're dealing with and all be talking about the same stuff. So, all right, let's get out your book and look on page 215 at the homework problems and see what questions we've got. Take a minute and look at problem 11. Let's talk about setting it up. They didn't give us any money. What are we going to use? That's exactly right. And that's how come I wanted to discuss that. On number 11, we're going to use 100. So let's do number 11 together. Find my paper. Okay. Notice that that one is a simple interest note, not a discount note also. Are you with me? When you calculate the proceeds, this actually is an exact simple interest note. Okay? So we're going to add the interest for the... Okay, let's talk about this one then. Okay. What are we going to use for... we're going to use 100. We've already answered that question. We're going to use 9% as our interest. We're going to use 60 days, and we're going to use exact. I end up with $1.48. Okay. This is a simple interest note, not a discount note. What are the proceeds to the lender? Oh, that would be the maturity value. 100, that's right. Proceeds are always going to be either the face value or they're going to be the face value minus the interest. You come and borrow $100, 9% for 60 days, exact. I'm going to cut you a check for $100. You would in the end owe me $101.48, maturity value. If this were discount interest, are you with me, Allison? If this were discount interest, you would subtract the 148 to get proceeds. Not 148, $1.48 to get proceeds, and you'd get 98.52. Okay, so we want to calculate what rate you're actually paying on this simple interest note. Okay. R equal I divided by P times T. Interest is $1.48. If it's daily, if it's daily or whatever, we still need to. It's only if it's 1 year that we don't need to do the conversion. Okay, it's because it was 1 year, and it worked nicely there. Okay, so what are we going to put here? 60 over 365. Okay, so this one was a true rate because it was exact. Are you with me? It was a true rate because it was exact. If it was not exact, if it was 360, then you would be paying a
higher rate.
What the APR actually is the conversion to a true year. This was a true year to begin with, 365, because it was exact. Okay. If we were to do, however, the 135 ordinary in the next problem, like number 12, your rate would turn out higher than the 12% because you were paying 135 divided by 360, which ends up being a higher rate to the bank than you thought you were paying. I'm looking to see if there is an odd one that is, number 7. Let's do number 7. It's, then that way you can check and make sure. Do you understand that on number 7 that is ordinary simple? Let's do number 7 together. Cassandra, do you understand what I'm telling you? If that number is 360, which is not an exact, then the answer will be different.
Right.
Okay, so let's do number 7. What did somebody get for interest? Anyone agree?
Yeah.
Proceeds. They are the full thing, right? $25,000 because it's a simple interest note. Okay. We borrowed it for 90 days ordinary. What'd you get?
13%?
How many decimal places did you go?
How'd you do? Oh.
That's the farthest out it'll go. It's 0.13.
Okay. Okay, I was thinking that was going to be out a ways different.
You did it 90 divided by 365.
That's right. Thank you. That needs to be 365. I'm sorry.
I thought it was
It
ordinary.
was ordinary, though.
Hold on, let me think about this for just a minute.
Yeah, that's right. I just got 13 as like a whole.
Yeah, I got exactly
whole number.
13.
I know, that shouldn't be right. Now let me think about that.
Because that'd be like 100. That'd be like 13.
Okay, check the back, see what they said.
It's 13.18. Okay.
What we need to do in here is we're saying, what time is it? And it's time in terms of a year. I think this has to be 365. Okay, just the time that you actually borrowed it for, in reality, is 90 days out of 365 days. Because actually, the real time in terms of a year is 90 out of 365 true. Does that make sense? How many days are there in a year? So it's asking in here, how much of the year did you borrow it for? 90 days out of 365.
That's only for
But in order to get it back to a true rate for a year, then we need year here.
So the ordinary is only just to calculate the interest.
The part of a year that the time actually is
The rate will always be out of a full year. Oh, okay.
Okay, here we go. Yeah. The time needs to be the time in terms of a year in the rate calculation, and we need to convert it to a true time, and it's really not 90 days out of 360. Truly, to be correct annually, it's 90 days out of a true year, which would be 365 days.
So do we just disregard
No, you use it to calculate the interest, but to convert it to an effective rate, the time down here has to be a real year. What part of a year did you use? And it's 365. Marilyn?
So we'll always use the 365.
In the
In the second half
the
was
rate
the problem.
calculation for
In
the
first
APR.
part- First
Yes.
half, we go by
That's
what it
exactly
says.
right,
But
APR.
the second half, we
Because we're
always go
converting
by
it to a true rate.
365.
That's right.
Okay.
Mm-hmm.
on the first one and number 3?
Okay.
I think I'm doing it right. If I'm not getting what they get in the back of the book.
All right, let's do it together. She said, I'm having trouble with number 3. Are we okay on this one?
Well, 1 and 3. I may have done both of them, but
They're neither one right?
not the way I did it.
Okay, which one do you want to do first?
1, I guess.
Number 1, okay. First, we're going to, they've already calculated the maturity value and the proceeds. What did you use for interest?
Let's do
R equal I divided by P times T. What'd you use for I?
I used 2,500.
It'd be 3750, wouldn't it?
Okay, if I gave you a check for great question, Cassandra. If I gave you a check for $2,500 and 4 years from now you paid me back $3,750, how much interest did you pay?
3750.
No.
What?
Oh, yeah, 12.
Where are you coming up with that number, Karen?
Subtracting.
Okay. The difference between maturity value and proceeds is the interest. I loaned you $2,500. You paid me back $3,750. So what you're going to use is $1,250. I think that'll solve that. Do you see, Cassandra?
Yeah.
Okay. And then we're going to say over the proceeds, or the principal, how much you actually had to work with for 4 years.
Still not what they have. Oh wait, I did it wrong again.
I'm getting 12.5.
Yeah.
If I calculate this denominator correctly, it's 10,000. That one okay? Go ahead and try number 3 then. What are you going to use for interest? In both cases,
The
difference between. You assume you borrowed $42,500, you paid back $43,500. The interest is $1,000. That's right. And I'm looking at number 5 and saying, when they calculated that, was it 45 days ordinary or 45 days exact? I'm assuming, and I'm not sure, that in the original calculation, maybe they want it to be ordinary, and then when you do the conversion, you want to convert it to exact, which would be 365. I'm not sure about that until I push the numbers. Do you see what I'm saying? I really think that on number 5, you've got to assume that the loan was originally 45 days ordinary.
But do you need to do that calculation?
Oh, you're right. You don't. You don't. That's the reason it doesn't say. You're right. On number, I'm not thinking as fast as I should today. We're going to do the $200. You're right, Karen. 17,400 times, and this is going to be 45 divided by 365. We don't need to know whether it was ordinary exact in the original calculation. I was thinking this was 2 parts. Yes, when you're doing APR, we're always doing exact. So we don't need to know whether that 45 days was ordinary or exact to begin with. I was thinking that was a piece that was missing, but it wasn't. We didn't need to know. Questions?
I'm looking for the effective rate. What's the difference between ordinary and exact?
When you are, which one are you looking at?
Any of them.
Okay. When you are calculating how much interest that you pay, let me get a sheet of paper. Take one example. I mean, just give me a number. Let's.
Well, I'm just saying, like, because what I picked up was it didn't matter what the difference was because of 365.
Are you looking at number 7?
I'm looking at all of them. It
Well,
doesn't
just
matter
let's
which
pick
one.
one and do it together.
I'm looking at 11 right now. That's what
11.
I'm calling.
Okay, here we go. We're going to originally calculate, well, since that one is exact, 9% is what it is. Let me talk. We're doing, in problems 7 through 14, we're calculating the interest first. We're going to use I equal P times R times T. If it's ordinary in time originally, whatever the time is, it's going to be over 360. This would be ordinary. Are you with me? In the first calculation. If it's exact, this will be 365. Okay? Keegan. But when we come to do an R,
I understand.
yeah, okay. When we have to do that, when we do time, it's always 365 for R. Because that's to come up with the APR. And I didn't make that very clear to begin with. Did I clear up the muddy water? Yep. Okay. Is there another question? If not, I'm going to go ahead and let them turn off the tapes. We can keep working. You can be working on your homework. I'll come around and help you.